A very good morning to all of the participants. First of all, thank you all for attending these courses. And our courses topic is the fundamental for XRD. And this courses is especially for the beginner, okay, not for the experienced PIC. Okay, so I'm Lo from, you can just call me Lo. I'm from RGSC. I'm the application specialist for this company. And before that, let me introduce myself. So I'm graduated from the UPM, both in bachelor and also the PhD degree in material science. Okay, focus on the solar cell material. And also I manage the RGS UPM laboratory, which you are sitting here. And also we do also provide the services to the customer of across the industry, and we also uh, provide the services around near to 2,000 plus of the service report annually. And I'm also a certified trainer, for professional technologies, and also a certified radiation worker. And I also train for the company that have purchased our instrument for over 20 organizations over the year. So included the private and public sector. Okay. So and also I provide a full cycle strategy lead of the pre-sales and after sales application support for our customer. Uh, yeah, up to date, I also able to accomplish 12 publications and also innovation rewards in total throughout my career. And lastly, I was but still I'm a technical mentor directing the application engineers, research students, and also interns in our company. So maybe just a brief. I already introduced myself. Now it's your turn. So can you all just give a very short introduction about yourself? Maybe your name, your age, where you working at, and also what's your position. Start from you.
My name, my name is Salman Jami from Kami. I'm 5 years old.
Sorry, I can't hear you.
My name is Salman Jami. Then from Shani. Ahmad. I'm 25 years old, and I'm working as service engineer.
All right. So how many years you work?
That's 1 year.
Okay, that's good. Then yeah.
My name is Shani. I'm 27 years old. Currently, I'm a service engineer for IBM Corporation for about 2 years.
2 years. Okay, I see. So quite an experience actually. So
My name is Muhammad Ikram. So I'm 30 years old. And I'm currently serving as a service engineer in ITS Corporation for about 2 years. My name is Sharon. I'm a service engineer for almost 3 years.
My name is Muhammad Zafar Iqbal. You can call me Iqbal. My,
it's okay, it's okay. No thank
I'm 56 years old. My position at IDS is service engineer.
All right. So seems like everyone is my colleague in this company, but from service team. But we are from the I'm from application team. So today, actually there is a customer should be coming or attend for these courses, but unfortunately due to some car broke down, so he unable to join this session. So we will treat this as an internal training from now on. So next, okay, now before we start, So just having your breakfast, right? So maybe we start with a ice breaking activity. So now I will give you 6 bottles of the unknown water or crystal. So you are given 15 minutes and you separate into 2 groups, group A and group B. Is that okay? Okay. And then you are given 15 minutes. You are required to, based on your experience from the A to E, 6 bottles, you write it down. What are the possible material? The selection is here, based on your experience. But remember the rules. You cannot open the bottle. You cannot taste the powder. Alright, these are some common materials. They are available in the convenience store. So yeah, let's start with this. The 15 minutes. Wait a while, huh? Each person get 1 piece of it. Form. So you are given 15 minutes each group. Every person you need to fill in out of you. Okay. Maybe this group take the ABC first, okay, and the group B take the 15 minutes. So same. Yeah, it's a it's the same. Sorry. It's the same. It's the same. So you need to, as if you look at the form, there is a visual clues and also physical behaviors. So you don't need some scientific knowledge. Like what do you need is you can ask Google what does the salt or sugar or any material should behave. Alright. So you can write down the characteristic. You think that the A is what? You need to give a reason. Why do you think the A is that material? With the physical and also visual clue. Is that okay? I believe this is not a difficult task, right? Okay, can you use your handphone to Google search it, to ask the Gemini, ChatGPT, Copilot. Okay. Later, after 10 minutes, you all switch. Okay. I will make it 20 minutes. Okay, your 20 minutes start from now. Okay, I will guide you all throughout the way. So you have salt, you have sugar, you have cornstarch, you have powder, you have baking powder, you have the measurements. Which one? You all can switch the sample over time if you want. So at home, did you all cook? No, cook. Sometimes. You all use the MSG. How does the MSG should looks like? Crystal. Crystal. Sugar also crystal. Salt also crystal. A little bit shiny. No idea. So all is look like the same thing, right? So this is a difficult task for you all. If so, if this is a difficult task for you all. Yeah, you just write it down and state the reason from the physical history. Or you can leave it blank first. You fill in the inner column later on. Yeah. Ah, Ajinomoto. Ajinomoto is MSG,
Yeah.
monosodium glutamate. Which one? You guess is MSG. Or is a white powder, white crystal. It's okay. Don't worry about it's right or wrong. Just write it down. Just write it down. Maybe you can. Maybe you all can categorize out first the fine powder and the crystal. Hmm. I use the fine sugar and fine salt. So not sure whether you all can differentiate. So basically, we can use the flow properties to determine it's a cornstarch or baby powder. For the sugar, salt, and also MSG, you can try to Google search with your phone. How does it look like?
What do you mean by it can flow?
You just this is the book, and then just make it horizontal, and then you can see how does the powder flow. Was it sticky or it's not sticky? Then from there you can get some idea.
So around
Mhm.
without concept. Perfect. Salt.
You need to state the reason why you cannot simply. It's all you can guess it with your experience. Okay, the first one is MSC. Yes. One. Share. Neither like you need to write it in. Yes. You all guess the B is a sugar. Okay. Let's see. What about C?
Salt has impact, right? For manslaughter and
But I use a fine salt. You have 13 minutes more. Seems like you try write a lot. You can ask any question if you're doubting something. Normally, baking powder is like or baby powder is like a little bit sticky, like so you can list it out which one. This baby powder or this cornstarch. So what's your guess, Xiaomi? Cornstarch. Don't worry.
Sudah macam kita tengok pasal ni lepas tu kau state dulu dia
Does it look like baby powder? Yes or no?
Ada aku cakap dia tak macam
So normally baby powder sticky or not sticky? No. My experience is it should be non-sticky lah, not very sticky lah. It's okay, you write it down. What is your guess? It's okay, just write it down. This is not the flour, it's a cornstarch. Flour and cornstarch is different.
Dari segi warna dan Sebagai bukan
You're playing carom, you need to use that powder, then you will know like which one is which. Powder. Yes. You can write it down. Your justification. Okay. So you can't differentiate the baby powder and cornstarch.
Yes.
Google search it, maybe you can find the answer.
So, banding dia dengan tidak lain.
So 5 more minutes, eh? Let me see your answer. Good work. Salt. What's the physical behavior of the salt? Do you cook? You feel the salt, right? Then at least you know a little bit about the physical behaviors, I believe.
I need to put more visual cues or one is enough.
It's okay. One is enough. As long as you have your own justification to why the A to F is that material. Based on your what's based on the material physical appearance. Okay. It's more. Everything okay, Iqbal?
Start seperti ini lebih detik panjang. In terms of studying fiction, but based on Google constructs with you what
Okay, 1 more minute, and you all share your answer and justification. Okay, each of you.
obviously so yeah so it's more related to yeah
Okay, Saj. Okay. Okay, everybody done. Okay, done. Okay. So maybe now we start to share your answer, each one of you, and why. So start with Ikram.
The first thing for the A level, so this is I think MSG because it crystalline, uh, the flow quite smoother.
Okay.
And then
The B.
the B for B I think is sugar. So the shape is not consistent and quite fine sugar. So and quite shaped well after shape it.
Okay.
And then C, I think this is salt because the shape is quite consistent between each of the salt. And then the flow, I think I can consider it as a medium flow.
Medium flow.
Okay. And D, I think this is baby powder, so it's quite sticky and when shake it will leave the residue at the bottom. Okay. And then E, so this is I think cornstarch, since it's quite fine powder compared to others and shake well and not sticky too much to the bottom. And then the last one, I think this is baking powder. So powder is quite soft and sticky, but not sticky compared to the baking powder.
Okay.
I guess.
What about Sharon? Do you think in the same way?
Yes, also the same way, but like to add on that information is kind of transparent.
Mhm.
That shows. Also flows freely. And same also the sugar. Since the particle size or the crystal shape is more oblong.
Okay. Not block.
Oblong.
Okay.
And you see salt. So why salt is just this one, the crystal shape I see is square manner, I mean like a cube.
Okay.
Mhm. And also flows. For me, it's flows not that smooth lah. See, it's more feeling.
Okay.
That's one of the characteristics. So So D is baby powder. Why baby powder is because it looks very fine, normally it's very very. E is also construct. It's one because it's look
Okay. Okay.
so it's very a bit
Hmm.
and that baking powder. My guess is slow, very slow.
Hmm.
And color is very white.
Ipa,
Okay, same.
Zen. Anything to add on? Answer, except? Okay. So,
Then the is I for MSC because the shape is like a noodle like.
either like,
So
so
you
they
can see that.
always put MSG in your cook.
No, I Google.
Oh, in Google. Okay, okay, I see. That's good. Okay.
And then the Google.
Mhm.
Was you can see the color is more shiny.
Okay.
Then salt,
Mhm.
for sea salt, and then the is with powder because
Hmm.
the tip the body due to residue. So
You mean sticking on the wood?
yeah. And then the is cornstarch because it's sticky and thick.
Okay, sticky and thick.
And the powder, the, the powder stuff. So fine can end up bad.
Okay.
So it can be easy flow
Mm.
and then
Yes. Zen,
for the
Yeah, actually same. But
anything to add on?
yes. Energy and trigger, you can see that the energy is more shining. Then trigger is also shining, but less than energy lah. And also, in front of the baby powder is you can see that sticking to the wall. There's the magic movement. The baby powder we see on our skin, so it's to be more sticky. And also, this one is the I think the contrast
Mhm.
because not easy to flow for cooking is the stick
Mm.
also before frying with oil lah.
Mm.
I stick the baking powder. I'm not sure, but the trigger lah.
Okay, okay, it's okay. At least you all have met a case. So the point is, now I won't review the answer first until the end of the training. Okay, so you keep the answer until the very end of the session. So later we will have a look. Is it your justification correct to make the guess? So now, why at the early morning we start with a icebreaker with such activities? I purposely ask you all to make your own justification to guess the material out because I want you to feel the difficulties. If you don't have any scientific instrument to prove that is the material. Because if let's say you are guessing the B and the C are the salt and sugar, right? If I ground it into a fine powder, impossible you are able to differentiate it unless you test it. But this is very dangerous if you working at custom, right? Because custom, they how the drug how they smart the drug, right? Is in this way. They mix with something and then you are unable to you know unless you use the scientific instrument. It's the same thing. So now keep your thought first on this material. What are these? Okay. So now, to our eyes, these are just some white grains, some white powder, some smooth powder. But for X-ray beam, they couldn't look more different because the X-ray will tell us how does the fingerprint of the material. From the fingerprint, we can know exactly. We don't need to guess it from the physical or visual clues. We can straight away get a pattern or profile and then match with the database to confirm whether the material is that material or not. Okay, later I will go through the details. Okay. And from this training section, what can you expect? You can remember peak framework. From XRD pattern, we have peak. Right, we have a lot of the peaks. And the peak, you can remember this way. See, you at least you know how to proper sample preparation for the XRD techniques. That's the first, because good result always came from good sample preparation. Okay. If you are able to explain the Bragg's law and fundamentals of the XRD. What is Bragg's law? Later we will touch it out. Okay. From the XRD technique, we are able to analyze and identify, and then you know how to analyze and identify out what are the materials. Okay. And the last K, you know why the material have their unique methods. Okay. These are the things you can expect from this training session. So today we will touch up on the qualitative only. For quantitative, there will be another section for that because it's you need to have a solid foundation first. Okay. So any question before we continue? So no? Shall we start? Okay, let's start. So first of all, it's about the basics of the XRD. Okay. So the XRD is an X-ray diffraction. It's a physics phenomenon that happen to collect the pattern of your material, and then we know what is the material. So the XRD technique is not only applicable for powder to powder. We can also use it for thin film, the bulk sample, the film, the fiber, the liquid. So if you mention, you can use in various or diverse industry. Okay, like semicon, cement, the hard disk. Okay, hard disk industry, liquid, fiber, like the cloth we are wearing, right? So these are all the sample they are able to scan under the XRD medium. Okay. So next, so XRD, given the name is X-ray diffraction, we need to have a X-ray to let the diffraction happen during the X-ray shine on the sample. So for sure, we have three main components. X-ray sources, which is the X-ray tube. We have goniometer. Of course, we have sample stage at the middle, and also the detector. In the middle way between the X-ray sources and a sample and detector, we have optics. Just like we short-sighted, we need to weigh the spectacles. It's the same physics. Okay, we need to adjust the beam up to achieve a better resolution or sensitivity. Okay, next. So the typically XRD data gives us is the intensity versus full data. Okay, remember this. And then this is the X-ray. This is a sample. This is the method. So what you can No, okay, we have a module for the XRD. Will let you understand. Do the module is so you can see this is the X-ray. When it move, this is a sample. Okay. So you can see the points dots appear detector, right? So this is how the XRD works. And when you shoot out, it's in the now it's in the point, but in the exact, it's in the cone. It's in the cone in this direction. But when we record, we only record the single axis, which is in this direction. So that's why the graph we get is the intensity versus 2 data. Why 2 data? That's why 2 data. The 2 data is the Bragg's condition. Okay, the Bragg's condition must be fulfilled in order to get the XRD pattern. Okay, so you can remember it is a 2D sine theta equals to n lambda. There is 3 parameters inside. D, theta, and lambda. But you all have been experienced with the maintenance of X-ray tube or XRD machine, right? I believe you all know we always fix the wavelength, right? What are the typical wavelength we are using? Copper. Only copper, or we have more? Molybdenum, yeah. So regardless of any of the target, we need to fix the wavelength so that we can get the responding and manipulated variable. So in primary school, you all have learned about fixed variable or constant variable, manipulated and responding, right? Because we need to fix something out, we manipulate something out, and then we measure what's the changes. This is how we do the experiment as well. So in this case, we fix the wavelength. We the changes in the d-spacing in the sample. The d-spacing is the atomic layer in your sample. Each sample, each component has their own authentic distance. And this give you the peaks. And it will give the peaks at different diffraction angle. Okay, so that's why you can get the series of the peak in the okay. Okay, so now what can you get? What other information can you get from the XRD method? So for sure, we can able to know what are the substance. Just like this case, it's a salt, sugar, cornstarch, MSG, or whatever. You can identify, is it a meth? Is it a drugs? Is it a Panadol? Okay, and also what are the crystal structure? What does that mean, crystal structure? Crystal structure is how the atoms arrange in a unit cell. In the later slide, I will explain. How was the quality? Is it a pure one? And also, what are the ratio? If you mix the sugar and salt, then what are the percentage for each of them for the part of the sample? Okay, so in science we have qualitative and quantitative. Just like qualitative, in this room, we have only males, right? We don't have females. So that's the qualitative. But exactly how many males is quantitative. We quantify after we identify out. Okay. So what are the crystals? You can imagine the crystal are the eggs from 99 speed month. When you buy the eggs, you have the tray, right? The box for you to put all the eggs together. But now you have a different grade of the eggs. What are the grades we have? Eggs. Every day we eat the eggs, but do you ever wonder what the grades we have? based on the size, right? You can have a compound egg, you can have a farm egg, you can have size A, size B, size C, right? So the point is, you have a different type of the eggs. When you place in the tray, it can be alternating with a certain repeating order. If let's say you purchase 5A, 5B, it can be A, B, 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 or you can A, B, A, B, A, B, A, B, A, B, right? So from this arrangement, it will give a different crystal system. Okay, in nature, we have 7 crystal systems: cubic, tetragonal, orthorhombic, rhombohedral, hexagonal, monoclinic, and trigonal. You don't need to memorize it all, but just for your information, to get the idea, there are 7 crystal systems in our nature. Next, okay, now here's come the important thing. When you buy the trays of the eggs, you stack it up, right? It's a crystal system, you stack it up. And then when you look at the tray of the eggs, you can have a plane. You are looking on this direction, diagonal, side, top, bottom. Each of them is a each atomic plane for your sample. It's authentic. Okay. So because of this plane, we are able to identify out for each of the material at which angle is correspond to which plane atomic plane. Because of the different distance. So we're referring back to the Bragg law. This one we fixed out. We only left the 2 and the theta, right? So what are the relationship between D and the theta? The D is the lattice spacing, the distance between the X plane, and then the 2 theta is the diffraction angle. So we fix this out. This is become constant. You can ignore the part of the. So what is the relationship? Can you all tell me? D and the theta, what is the relationship? Directly proportional or inversely proportional? This one become fixed, right? This will be moved over. Inversely, right? So what does that mean? It means that the D spacing increase, the angle will be decreased. Or in another words, the D spacing decrease, the theta will increase. Means that you can imagine that as this time, you have the sample of this, that with a different D spacing, you can see that we have blue, we have red, we have green, right? Can you tell me which one is the biggest D spacing? Which color to which color? The blue, red, green. The blue. Following? Red or green? Red. And then green. So that's why, based on the equation, the first peak appear is blue because of the red slope. Okay? Following red, and then green. Now clear? Now I think you all have get substitute the ideas lah. What does it? Why you get the series of the peak in your pattern? And normally for the service, you scan the silicon powder, the peak must be 28.4, right? If I'm not mistaken. But in the if you think out of the box or out of the maintenance side, we have series or different kind of the sample. You think from the application side, you must know how to explain this pattern. what are the things the pattern tells us. Okay, yeah. Okay. Next is the materials inside for the HRD data. So we already get the pattern right, but we need to know what are the insights we can get. So from the pattern itself, first always we can know, is it a crystalline or amorphous? Do you all know about amorphous? Okay, later I will explain. When we can able to conduct the qualitative, means that we able to identify out this is a sugar, salt, cornstarch, baking powder based on the pattern. Because the each of the material is authentic like human fingerprint. You can never fake the pattern. Okay, and then you can determine out the some R&D purpose information like crystal quality, crystalline size, and also what's important, you need to know from the intensity, we can know the quantitative. If the salt is present in the pulse of the sample, pulse of the powder, then how many percent quantitative? Okay, and also some R&D solution. This one I will skip this. Okay. And what are the crystalline and amorphous? Do you all heard about the UVBs, the cuvette they are using? They are small glass cuvette. Or do you ever know about the quartz? Quartz is what? SiO2, right? Quartz. Why some of the glass window is expensive, some are not. But the raw material is the same. SiO2. Why? Because of the arrangement of atom inside. So that's why when the glass window crack, it will crack in a random way. It won't crack in a very sharp way, right? Unless you go and cut it. You use a diamond to cut it. Otherwise, it will crack in a random orientation because the glass window normally are amorphous. But for scientific purpose, they are using quartz, high crystallinity quartz. Okay, because the atom is ordered repeatedly ordered for the entire system. Let's say this is a spacing of 2.5 angstrom, with 2.5, 2.5, 2.5. That's why the intensity will sum up and give you a very high intensity. But for amorphous, it's just like a distribution graph. It's a range of the P spacing. 2.5, 2.4, 2.3, 2.2, 2.3, and then we give you the peak like this. It's a range instead of a single sharp peaks. Okay, not all the elements are in crystal. It can be in amorphous, just like the glass window we have. Why do we need to know about this in the material? Any idea?
Draw out the things that we want.
Sorry? Why do we need to know it's amorphous or crystalline? Do you have any idea? Because the way of the atom arranged will decide the properties of the material. Okay, just like you go to construction site, then we ask the COA, certificate of analysis, for the material, whether the material is suited for the building. Okay, or just like stainless steel we are using now, we have food grade stainless steel rack. Then what are the things? Then we need to justify out with the SIP. Okay, like cement. Cement, what are the mainly cement composed of the element? We have calcium, we have silicon, a little bit active. Depends on the products. The point is, the main ratio is a C and a Si, Ca and a Si, calcium and silicon. If you vary by 1%, the whole building will collapse. So the selection of the material for cement material is very important because of the mechanical properties it can withstand. Okay, clear? Also, the gas you can see it will just a scattering peaks. It gives you nothing. Just a scattering exponential graph. So normally the graph we are getting depends on sample. If your sample consists of amorphous, also the crystalline, it will give you like a hump that peaks. If like silicon powder is very crystalline, it just give you a peaks without hump. So from there we can get the idea whether it's a crystalline or amorphous. So far, any questions? Okay. Okay. So qualitative of XRD, the XRD normally is used to identify the structure of the material. So unlike XRF, it can tell us what are the elements. Or in easy words, the X just now I mentioned, it can tell you the X is grade A, grade B, or grade C. You purchase 5 grade A, 5 grade B, it will give you 5 grade A, 5 grade B, but it never tell you how the grade A and grade B arrange each other. It can be A, B, A, B, A, B, it can be A, A, B, 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 B. So although you have a same elemental percentage, but you can have a different arrangement of the. So normally that's why in XRD and XRF, they are complementary. Okay, normally customer will buy two at the same time, I believe, right? Because they need the elemental to support the structure. Okay. Yeah. For example, you can see we have PaO2. PaO2 is a titanium dioxide, is a common material used in our reality. So the pen is in white color because we add some butyl white color. But for the photocatalysis R&D or the solar cell, we are using photocatalysis MRT space. Both of them are PaO2, but it's a different arrangement. You can see what is the difference arrangement of atom. You can count out how many atoms of the Ti and O. Actually, it's same with this one, but the way it arranges is very different. Okay. Next, just now we mentioned about qualitative, right? We go more deeper. It's about quantitative. We need to have a number to quantify how many percent for each of the sample. So you have 3 pounds of the sample, you mix it, and then you scan with XRD. The XRD will give you the pattern for all the 3 samples, but overlapping each other. Okay, just like you can see, this is for the one faces. You can see one faces, another faces, and another faces. You will stacking up each other. But if we decode, it will become as individual one. 1, 2, 3. Okay. This is quantitative, but based on the intensity, is quantitative. Great. Okay, let's move forward. So quantitative, we want to quantify the things up. They have 2 different methods. First, we quantify it with calibration or standards. We purchase the standard, NIST, Buxana, and then we build the graph. From the norm, we determine a norm. That's the first. Second, we use the theoretical way. We do the fitting or matching. So you can see that for the external standard, just like the cement factory, they always chase the standard because it's a certified value and then with a non-intensity. And then we can build out the graph, give you a very good correlation. From the non, we determine a non from your sample. It must be relative. You have a comparison, then you can know the exact condition or exact percentage of the phases in your sample. This one quite straightforward, right? Okay. But for the, if let's say the sample is R&D sample, you don't have the standard, then you need to use the theoretical way. It means that you use the fitting to compare the intensity. Okay. In the logical thinking, higher intensity means what? More or less percentage. More, kan? Yes, it's the same. But you can see it's only the comparing the intensity. But another one, relevant refinement, you will do the fitting. You will fit all the profile. We have pattern and profile in XRD. But we never call XRD a spectrum. Remember, spectrum must be related to the changes in the energy. But XRD is not because the wavelength is fixed. The copper K alpha we are using is fixed. We are not manipulating the copper K alpha. But for XRF, we call it spectrum. But SEM, it gives you intensity versus 2 theta, right? But here also intensity 2 theta, but it's a pattern or profile, it never a spectrum. Okay, so pattern is only comparing the fixed position. But profile, we need to include the width, the pitch shape, the complete information. Just like you have CV and resume. Which one more complete, CV or resume? CV. Resume is just a brief, right? Pattern is resume. Profile is CV. Just like the profile of yours. Very detailed. Okay. So quantitative, normally we need profile instead of for theoretical method, we always need profile instead of pattern. But it depends. The profile, the pattern is smaller under the profile full method. It's just that the you can think in that way like CV always higher than the resume. Resume is just a brief one. Okay. So for example, when to use the direct method and the more detailed method is a RIR available. So you can see that we have 4 samples. Mix it. This is the exact because we know we mix it, we know it. When the value give you in the RIR, it's quite different from what we mix. What? Because of overlapping. The peak give you in the XRD pattern is best because of the wave. Wave got what properties in physics? If you go to the seaside, you see the wave, right? What is the effect? Why there is a wave? Interference, right? What is interference about? What is interference about? You can have a constructive or destructive. If you have a peak wave, and bottom peak wave, you add together, it become step. But you can 1 + 1 will become a higher wave. Okay, so the same thing happened here. If coincidentally 2 peaks are overlapping each other, it will give you a higher peaks. But when you do the IRR, which is typically just compare the intensity, you never know the intensity, how many percent is from phase A and phase B. But if you're using the fitting, you can usually distinguish out how many percent of it from phase A and phase B. Okay. So far, any questions? No. Should we proceed to the next section? Because just now it's more on theory, some fundamentals. So let's recap what we have learned so far. Is that okay? So XRD, what is the core principle of XRD? When we talk about XRD, what is the core principle? Brett's law. Brett's law, right? So as what is the Brett's law equation? Okay, good, very good. So what is the D about? What's lambda about? This species, lambda, wavelength, theta, diffraction angle, right? Okay, so how does the XRD give us this pattern? Through the diffraction, Brett's law, right? And then what are the information we can get from here? This spacing. From the spacing, we can know pattern. We can know what are the material. Okay. What are the material? Okay, clear. And then of the peak correspond to what? No, each of the peak in one pattern. The plane, right? Atomic plane. Okay. So please remember this until the very end of the session. Okay. So now we are going to talk or share about or learn about the sample prep and also the measuring condition. But we will start with the sample preparation first. So still remember at the very first slide, when it will diffract in a cone, right? But we only take a single axis. This is here, right? Agree? Agree or not? Yeah. As the detector move in this way, so that's why we correct this. The concept is all the direction. Okay. So most important, we need to ensure the particle size is fine enough. You can see which one is better and tell me why. Any idea? Neither. Why neither? Mostly match. What about this and this? Blur. This one? Putuskan. So we call it spotting, like a spot instead of a ring. In XRD, we want this because first it's representable. This is a detector, huh? It move in this way. You can see that no matter which axis I refer, it still give you the same intensity. So that's in the case, the quantitative always correct. But in this case, the intensity gone at some of the points. You scan here, you get you scan here, you get nothing. You scan here, you get the intensity very intense. So it will affect the intensity in the graph. Okay, and this quantitative is not correct, not accurate. If you run too fine, your particle will break up. So basically, it will give you a very wide, okay, in for that phase or for that plan or for that fix. Okay, let's see the effects. So why we always educate the customer sample must be finely ground. This is the main reason. You can see the red color is from the database. The black one is what we measured. You can see the difference. And what are the difference? Can you tell me what are the difference? So which one fit the most? Left or right? Left. Why? Because the red and the black near to each other, right? But what happened to the right side? The intensity is not matching with the database pattern. So that's why we still able to get the same peaks at that position, but the intensity have been varied because of the spotty ring. Okay, so if customer complaining about reproducibility, repeatability means that you scan the sample, you get this pattern first time, no matter how you run, you always get back the same pattern. Repeatability. Okay, so customer complaining the repeatability means that maybe something wrong with the sample prep. It's not about the machine. Okay, you can verify with the silicon powder 2 times whether you get back the same position, same pattern. If same instrument no issue, it's sample prep issue. Okay, then we need to educate customer. You need to find out the sample and microns. Okay, and how we can prepare the sample? We always use the rider. We can use the electric milling, ball milling, use the ball and chaotic motion to crack the particle, or we can use the manually use the RD mortar. Okay. And another thing is very important is about the ancestral error. This is the sample. Sometimes customer will prepare the sample above than the focus. It will make the focusing being part of the focus, and thus it will make the peak shifted, core pattern shifted. Okay, how you are going to imagine? You can see from here. This is a sample. If I move, you can see the peak at here, right? You can come closer and have a look. If I move upper a bit, you can see how the laser beam move.
Also great.
Yeah, the whole point will be moved upwards if you put above. Okay. Which you have a look at here. It will appear at the higher end. Okay. So if customer complaining why the peak is shifted, please have a check with the SI whether it's 28.4 for the goniometer calibration. Clear? Okay. You can see this is right position. This is off position. 0.3 millimeter off from the focusing side. What if your sample you didn't pack it properly? This will what happen? You can see just now the peak shift to the lower angle, right? Now in another way, shift to higher angle. Okay. When you do the analysis, you are facing a lot of difficulties. Okay, yeah. Any questions so far regarding the sample prep? What are the two things? First, grain size. Second, eccentric error. Okay. Next. So now we will have a physical or practical section for you all to prepare the sample. Okay, you all try to pack out the sample. Normally, you all maintain the machine, but you didn't clear the sample, right? Now is the time for you to try. Each one of you take two, okay? So one to make the sample flat, one is the holder.
Yang ni lah, ni belakang lah. Dia kena rakan itu kan. Kalau dia dalam, dia letak kita tengok.
So now let's have a try. Let's your glove on. So you can see that actually is just put the powder at the center, just paint with the glass pipe. But for the details, I will show step by step. You all follow my step. We will start with this fine powder first. Maybe this one. Or the B. Shall we start for the F? Okay, F. Okay, let's try. So make sure all of you get a single sheet of the paper. Following my step. My color.
So sample is 0.5, right?
0.5. There's two depth is 0.2 and 0.5. Make sure you're using a 0.5. 0.2 normally is for the pharmaceutical sample. Okay. Make sure it's a black one. Right? And then all of you, following my step, I will pass around later on. Take the powder, put at the middle.
I mean,
It's okay, you can put more.
oh no, I mean our sample is
Fine enough.
fine enough. Or
You need to go pass through the seed. It's okay. This is not a gold powder.
so to the side, let's say if we use milling or the we assume we have some fine.
Yeah, the contamination. Yes. Depends on what is a laboratory practice like. If they clean properly, shouldn't have the machine. Okay, done. So now what you need to do, just following the second step. Form a smooth surface using the back of the glass sample plate. But when you want to make it smooth, you need to try to make it flat as possible. The angle must be as low as possible to the surface. So it's like this. See how I do it? I scratch it. Try. At low angle, not high angle. Kena low angle macam yes, lower angle, lower, holding like this, and then you, yeah, like Petra, you can see. Okay. The extra one you can pull it up to the tissue. No, no worries. Okay. And then we clean the side. We need to ensure we clean the side first. Okay. Repeat for the four corners like this. Like this. One corner, two corner, three corner, four corner. Clear? Try it out. Okay. Yeah. Petra very good. Okay, and then you clean the others first, the top of the roof. Okay, that. Maybe you try in this way, you can have a better effect. Two finger, and then you just drag it across. Yes, better right? This one also good. You have to have a lower angle. You use like this. Lower. You need to apply the angle as long as possible. Repeat until you pull nothing out. Or repeat. Very good. You all. Change. Able to done it? Okay. Who first? Want to show me? Who first? Huh? Okay, now after you have done right, there is one way to verify whether it's totally flat or not. Because some of the time, at some of the corner, it will be higher a bit, some of the corner lower a bit. So that's why I ask you to drag across 4 corners. And how we check whether it's flat in all the way? You use your glass slide, tap it gently in the diagonal. If no line came out, sample prep is very good. Try yourself. Very good. Yeah, this is a correct way. Remember. This one you see got line. Then you maybe at that region it have a higher right. Then you drag from another opposite direction. Okay, very well. You want to try another powder? Try. You want to try sugar? Okay, now later on I will. Sugar is next one. Maybe we wait for other first. Sugar or salt? I also don't know which one. Okay. Let's see. Cross check. One. Good. 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 Okay. Pass. Sorry? Huh? Ah. 0.2 or 0.5? So that's why we never just pack it and then run it. We need to drag across it. So for those who already done, let me get the bottom. Okay, it's okay. You can pull it up. Simple. Just pull it. And then wipe it with the alcohol.
Hari itu di bawah di bawah.
So how to clean the sample? Let me show one time. So let's say this is a sample. I've done. Put the alcohol on the tissue. Just wipe it up. Make sure it's dry and then you can continue for the next time. Okay, done. Johnny? Huh? Huh? Okay, okay. So now you can see we are using the C, okay, the unknown C crystal. So for crystal, impossible for us to prepare the sample because it's very coarse and it's not be pressed. Like this, you can see, you can hear the sound scratching. So what we need to do, right, with the Oka method. Okay, you can put more. The unknown crystal. And then ready actually. It will become a very, very fine crystal. Want to try? Maybe I take out my sample first. Or try. Try. For the sample C. Sorry. So if you want to know whether it's fine or not, so you can pass through the mesh like a flap. Okay, this is a weighing paper so that we can collect the sample. So the mesh is 300, it's about 60 or 7. So still not hitting the red micron. You need a lot of time for that. But this is for practice purpose. You can pass through the C first. Have a try. Yeah, let me get bigger. Bigger. Take them to try it. That's not.
Grind. Yang apa? Abuk.
It's not true. Is it? You want to check? Macam ni. Ya tu. Maksudnya tak fine lagi. Sikit pun dah ada. So we need to grind this one. For this final particle size. Once the metal fit, we can use the ball milling. Now maybe we try one with the ball milling. Is that okay? Tapi kadang besar je. So this is a milling jar. The milling jar, we have a different size of the bowl. All this material is tungsten carbide, WC. So it's very hard material lah. So never crush a sample which the jar material are softer than your sample. Okay. Means that your sample must be softer than the jar material. If harder, then you are grinding the jar material instead of your sample. Okay, so we need to apply a different number of the bolts. Have two. My ratio is 1 to 3 lah. So plus 6, 2 big, 6 is more. Here already have 6, so another 4. So this is a tungsten carbide bolt. Size. So now we try to compare the difference conventional manual grinding and also milling grinding. So I will put one. I only grind for one jar. So who want to try? Come.
So the amount of the ball is
depends on your sample. This is a matrix effect. So one cut. Put your sample inside, put the ball up. You can put more if you want. Yeah, and then just top it up. And then the another jar leave it blank. Okay, let's go. So this is the milling machine. So our onion. Alright. Open the door and put the jar inside. Yeah. But it need to be balanced. Although the another jar is blank, it doesn't have any sample, but the weight is negligible compared to the whole jar. Okay, and then it must be even number. You cannot use the odd number to grind the sample. Okay, this one there is two lock. First, put you on the bed and lock the down one. Lock the upper one. Sorry, lock the upper one. And make sure you place at the middle. Yes, settle. And then you lock the yeah. Because when the grinding, uh, the knot will be loosened. So we need to have a double safety lock. Okay. Come, try for another one. Try to adjust the all right. And then we close the door. We log into the USB. Let's say normally we grind in this axis, right? But if we on this button, we will grind in this direction as well. Okay. So now I just leave it turning. Okay. Any volunteer? Cheryl? Yeah. Just log in. Yes. So to set the parameter, so highest speed is 800. To set the parameter, you can see first, you can have a sequence, you can program out the grinding process. And then either you want to grind in the forward direction or reverse direction. Okay. And also the speed maximum is 800. And what is the holding time? So now we click forward, click here, you can change forward, reverse, stop. Okay. So what is the RPM? Let's say I want 800. Enter. And then hold for maybe 5 minutes. Okay. You want to change the program, the sequence, 2, 3. Okay. Maybe forward 3, reverse 3. Put that way. Okay, now is everything is been done because we will stop at the third sequence. It means that we only grind forward 800 3 minutes, reverse reverse 800 RPM for 3 minutes, total 6 minutes. Once everything is done, we can set and initialize. Okay, and then stop. And pay attention to the sound. If there is some weird sound, means that you didn't log it properly. So yeah, you can hear the sound, right? Yeah, it's Python. Both of them Python. Maybe we put 500. Set to 500 and start. Hmm. The sound won't be like just now. Need to stop every sound weird. So maybe we go back to there, wait for 6 minutes to continue the manual grinding. We'll find. Yeah, try to pass it through. So you can see going to 60 micron is not an easy task. 60 micron already not an easy task. So 10 micron you need longer time, especially manually. Yes. Got a good crunch. Yeah. Need more grinding. Enough on enough. Enough or not? Time to back into the sample order and see whether it's done or not. Yeah, 300 mesh. And then lower. Like this. Right. And then as far as possible. Maybe you pick first. Pick first. Well, when I go home, I try to keep food with it. So the grinding is done. It's okay. You all finish here first. Then we compare. You can't. You put it first. I think so. First. And then you try to rub it around gently. Yeah. Gently. Clap, clap. They're not sticky. Yeah. You need to grind more. Not fine enough. Okay. Okay, you pack it, smear around. Smear around and then you get rid of the rest and then you start to swap at the corner. Right.
Oh.
You have to smear around until it's flat. Not like that. Or you do like this. Straight away. Go around. Okay. Halus. Ada, jangan. Ya, ada, ikut kan? No. I stopped. We have another one. Mortar tester on what? This looks okay. Try to move it down to see whether the sample will off. 41. Then, yeah, it's very good. We need another. You can try. You can try. I think it's enough. Try to pack the sample. Remember, check two things. One, sample fine enough and pass through. If the sample, if let's say you have sample, some of them is pass through, some of them is not. You need to ensure the sample that have not passed through, you need to further grind. Otherwise, some of the material is hard, some of the material is soft, then it will, the result will be inhomogeneous. Not homogeneous, then the result will be biased. Two things just to remember during the sample prep. First is a sample fine enough. Second is the eccentric error. So that's why you need to check with the perpendicular direction, right? Check whether there's a line. If there's a line, then it means that your sample you didn't pack it properly. Another one, you need to smear it first. Bagi dia masuk dulu. Yes. Then we try to drag across 4 corners. Yeah, another way to check is for see from the eye level. But to double confirm, we need to check with the perpendicular method. Okay. Now, let me show one time. This is your sample. Sample it. Not enough. One powder. Just gently, you don't need to push it inside. It perpendicular method. 1, 2, 3, 4. Right. Okay, check. No line. No line. No line. Repeat that. Gently. 1, 2. Still have a little. Let's see. 1, 2, 2, 2, 3. Very good. Cái nó chặt gì? Nó chặt rồi thì là wow, so much I mean, a lot. So in later, let's say customer want a refresher training, very basic. After you found out customer maybe didn't practice a proper sample preparation,
Okay.
then you need to teach them in this way. Yeah, like how I share to you all today. Sometimes customer need some reminder. They assume the sample will be give a perfect result as long as that they just insert the sample, but actually it's not. Yeah.
Tengok dia tukar. Satu tu kan? Okey pakai ni.
Yes. Then you can see it won't fall down. That means that your sample packed very well. And then no eccentric error, particle size also no issue. Ah. If you go and it came out, then it will fall down, right? Of course. Yes. Yes. Put on the table lah. If you want to make it, yes. How to smear it? Yeah. That is. Put around. Get it right across. It's okay. Okay, right. Okay, if rabbit, I think it's okay. Let's move to have a look on the grinding. Okay, how was the grinding of that? You done? So any volunteer want to open? Yeah, I open and check it out. So we open the downside first, the bottom, not first. Ah, yes. The bottom not first, yeah. Okay, let's have a look whether it passed through all the sample will pass through the sea. Let's see. Come. Come. It's okay. Just take it out the big bowl. Small bowl, just split it each. Yes. Yeah. It's okay. Just pour it out. Let's see. A lot, right? Yeah, yes or no? See. You all right? That's why we always mention to customer, if possible, try to invest in electric meeting. See? Yeah, see, easily we can get a lot within 5 minutes. But you all already grind for 3 or 4 times, right? Yeah. So there's a difference. Okay. So now it's my turn. I haven't done mine yet. So now, actually it's the same. Just that product that you get. Again, for this kind of sample, smear it. You can smear it easily. Okay. And then drag across the corner. 1, 2, 3. And then the last corner, 4. Okay. Clean the side. And then you check with the perpendicular method. No, no, no. Okay. And then you clean the side. Use the tissue. If you're wearing the gloves, should be no issue. Now the sample is ready to scan. Okay. Alright. Any questions so far? So which one you prefer? Mailing or handwriting? Okay. Or Charu, you try to smear it. Easy, right? Okay, now let's move to the next section. Okay, everyone. Yeah. So let's move to the next section. Just click it. So you can see just now we have gone through the sample prep, but not only the sample prep, actually there's three factors will affect the data quality. First, instrument condition means that what are the slip you are using, what are the attachment you are using, what are the detector mode, that one is related to instrument. I won't go deep on this, I just touch and go. So that's why we start from the sample prep first. Where's the error came from? Sample prep. And now the third one is measuring condition, how you measure your sample. So this is the slide showing that the relationship between the scan speed and also the statistical fluctuation. So in easy words, if you slow scan, you can see the noise will be suppressed. You scan it fast, it will have a very high noise and you can't even differentiate whether it's one peak or two peak. So this is very important. If customer mention why my sample, my data is very noisy, you need to ask them sample prep, is it the cause of fine and also the measurement condition? Okay. So you can see another is a sampling step. So sample prep, two things is the particle size and also the eccentric, right? But for the measurement, also two things. Scanning speed, scanning step. So from this graph, what you can know? Tell me what you can see. The red or the black vector, the peak. Why? Why the red vector? The peak shape much more obvious, right? Compared to black. And the black, the peak first, the peak is not in a perfect shape. Second, you might miss out some information. Okay, so you can see this is normally what we apply 0.02 degree. So the sampling is 0.1. You can see you miss out the point. Actually, there's a two peaks because you jump skip the step, so it will become one peak. you miss some information because as I mentioned in the early of the training, fix means what? Information. Right. So in this case, it means you lose information in your sample. Maybe this is another phase, another compound, but because of the measuring step, we set it wrongly, we can't identify. There is another compound in the sample. Okay, so again, normally we advise customer to apply 2 degrees if possible, but 2 degrees, if let's say you cover from 10 to 90, you cover 50 degrees. So it will take how many minutes? Can you count? 2 degrees per minute, but you need to cover 50 degrees. Just simply divide it 40 minutes. So you can see the longer you scan, the better the data. But of course, the productivity will be lower because you need longer time to scan. But quality much more better compared to this. So depends on what customer need. If customer need pattern, you don't need to scan it long because the pattern only need the fixed position to identify. But if customer want precise quantification, need profile, you need to slow scan. Okay, so that's why we always need to ask customer, you need profile or pattern. Although both are same, what I mean is profile is way more deeper that give more information. And also the scan step. You can see just now I mentioned we jump skip the points, it will become 1 bit instead of 2 bits. But if we make it too smaller step, the noise came out. Although the peak is very complete, very beautiful, but you can see the noise. But in science, we talk about data quality. Right, data quality will decide the accuracy. Correct? Agree? But how do we know what is the thing define the data quality? Any idea? In science, we already talk about 2 things: sensitivity and resolution. What is sensitivity about? What is the meaning of sensitivity? I'm very sensitive, my nose. I can smell. My nose is like a dog, very sensitive. I can smell my another opposite of the roadside. I can smell the pisang goreng punya smell. Sensitivity, right? So what does that mean? Lower, very low concentration, you still can detect because it's very sensitive. So, but what about resolution? Can you ever differentiate the smell of pisang goreng or Lego? It's different smell, right? That one is resolution. Yeah, get it? So that's why sensitivity in science is about how low the concentration can detect in the instrument. So as low or as high as possible. Kalau nak, the sensitivity yang baik. Concentration yang lagi rendah atau lagi tinggi lagi baik. Lagi rendah kan, lagi rendah dan dia boleh detect lagi sensitif. Is it? So resolution, ability to differentiate the peaks. Yeah. What we always use FWHM. Remember? Full width maximum. This is maximum. Half of it, the width. But FWHM. Smaller better. So means that your resolution better. Easily to differentiate the peaks. And 2 of them. Another 3, signal to noise. Signal to noise. Peak to background. And also reproducibility. No matter how many times you scan, you're still able to get back 99.9. Pattern, similarity. This is the 5 things to decide a good data, quality of data. Okay? So now, without further ado, so we still have 1 hour 30 minutes. So we will start the measurement. So for the sample, you can prepare now. Okay. So now let's move to another side. So any volunteer want to start the PC? We follow the step. Okay. So first, double click the Smart Lab Studio, the software. Already double click? Okay. So we will take about 30 to 60 seconds to start the system. Just a refresher for you all. I believe you know a little bit know about this, right? It said it can be only run one at the same time, right? So this one, seems like you already experienced with this, we will just maybe 15-minute quick share. After that, we go back to qualitative. I believe this is what we want to learn, right? Most of the time. Yeah. So this is an XRD, benchtop unit. Now I can't open the door yet because of the system initialization. And also you all are the radiation worker, right? So I believe it should be no issue like to operate this machine. Okay, now for so click the XRD measurement tab button and then click COM to start the X-ray. And okay, maximize it. And you can able to find the column right. Step up, step down. Yeah, click. And then we give this. And then you click right. So yes. So in 8 minutes, the X-ray tip need to aging like our car. So in 8 minutes, we are the X-ray XRD is ready to use. But before that, while the X-ray already on the land wheel, set up. So but on the meantime, we can open the door. And no worries about the leakage. So if I'm a survey meter, you can see the survey meter is there's no radiation leakage. Okay. Now it's background. So you don't need to worry about the leakage. Okay. So now you can see, just now on the in the slide I showed is the floor stand model. This is a bench top model. We have the X-ray tube. We have the volumeter. We have the detector. Okay. And we can insert a different sleeve. Okay. For example, this is a K beta filter. What is the function of K beta filter? To block what? Why we need to block the K beta? Because according to Black's law, what is the Black's law equation again? The lambda need to be what variable? Lambda. Fixed, constant, or manipulated? A fixed, manipulated, or responding? Fixed. So if let's say you have one plan, you have K alpha and K beta, they give you two peaks. We don't want two peaks. We only want one peak from one plan. We don't want two peaks from one plan. So this is the function to block another K beta. So different wavelength have a different filter material. For copper K alpha, we are using nickel with the thickness of, let me check, I think it's 1.5. 1.5. And also we have the solar stick. You can see inside actually is the metal slit placing vertically. Okay. What is a solar slit? This is the slit to reduce the Abera effect. The Abera effect in the easy terms, it will cause the peak to be asymmetric. So what does it mean asymmetry? Symmetry and asymmetry. If the peak like this, the left hand side and the right hand side, the area is the same. It's symmetric. It's good. But asymmetry, one side will have a bigger, one side will have a bigger area, another side smaller area. And then the solar slit is used to produce a symmetric peaks. Okay. And we also have the divergence slit. We can have a different divergence slit. You can see the pass around. This is solar slit, divergence slit. You can see. Yes. What is the difference? Can you tell me? The area, right? Why we reduce the area? The divergence is to produce a better quality of the data. Increase the resolution. Okay, so that the peak width can be controlled. Make limiting slit. I mentioned incident height slit. Make the different side, right? This is to control the width at this direction. Okay. So if your center, for example, have a very little amount placing at the center, not even the 1 cm. So you need to apply a smaller slit size. Otherwise, all the signal from the folder will come. Okay. And also, we do have a special folders. This is for the zero background. So each zero background costs you into 2,000. And you can pass around, have a look. The zero background is they cut the silicon wafer in a certain direction so that the spacing will appear only after 120 degrees. But mainly we are measuring 0 to 90. Maybe we start from 3. We never measure until 120. Depends on sample. Okay. So that's why you can see this is zero background. Although you have a very small amount of sample, you still can measure it. Silicon. silicon die. This side. Only two side. So once we open, you can see that the shutter is on. So if we close it, we place the survey meter inside. But now we have another 2 minutes left. Maybe we can stick in the sample first. We take the sample. So sticking the sample, yeah, in this direction. There's a big gap, right? The big gap should be over there. If let's say you have some spatial sample, what if my sample is cut? You can use this one. And then there's a right hand to put your sample here, but still you need to pay attention to the concentric area. If too high or too low, forgotten, shifted right. So let's say this is the bulk things I want to measure. There's a lock here. Usually to adjust the match. You say I want to move it. So far, any questions? 30 seconds. Yeah. Yes. Yes. Or if the center is not flat, this bench top can be only build the red and panel, which means that if you want to measure the uneven surface, something like this, you need to have a parallel beam CB, which is only applicable on the closed-end machine for our system. So that's why if customer says, why my sample result very weird after I measure, after you look at the sample, it's not even, then you have to educate them, you have to share with them. Actually, the PV is not suitable for uneven sample. Okay. Okay, now please put in a sample and we can start. And remember, when you're running the SRD, the survey meter must be on all the time. Okay, oh, providing hydrogen space. So we can put here. For the data, either you can put here or put here as a set. What? So, I answer. Yes. Okay, so let's say another thing is that you can have a holder, you can have an ANC as well, automatic sample changer. That one I will show later on next time. But this is the spinner. You can feel that you can spin around. Okay, why do we need the spinner? Any idea? Why the sample like this? Better, right? Why we need to spin the sample? If we spin off the sample. Because some of the sample, they are coarse in nature. So if you are measuring a coarse particle, the spotty ring will be in that case, the intensity will be very. So in order to how to say, average out, we need to spin the center. Okay. So now what we do, we need to remove this thing, put it here. There's another screw we lock here. And then this, because we need power to be function, so it will be attached to here. And then this one can be removed with the electric. Right? Next is, and then this center holder, this is facing above, this is below. So your center will be placed at here. Try to pass around and have a look. It's magnetic. But if you want to have a glass, yes, you do have. But it's not spinning. It's not spinning. Okay, you want to make it flat, you have a special center preparation. That one, I went to check where I think okay. Also the same way, just use a glass like so one speed. So let's put it back. Remember, split it in this way. Center it if possible. If you feel it's looser, you can use the Allen key to tighten it. Right. So if you left or right, if the X-ray is here, then your glass, the signal from glass light reactors is try to center. If you think it's looser, then just like that. And then you can feel differently. Okay. For the book. Then we can close the book. So now move next. So click the home. Okay. And then go to general measurement. General measurement. Oh, break it down, break it down. Okay, general measurement. Double click the general measurement. And then you double click the measurement. And then it give you the icon like this, right? So you can expand the icon. For the benchtop, it doesn't have a sensing system. If you notice, most of the screen, they didn't have like smart lab. Our benchtop system, they have a sensor behind. This one is for the recording purpose only. It's clean here for benchtop. Yeah. And then these are the things we need to key in. Okay, we key in the angle. We key in the angle. Where to start, where to stop. What is the step size? Just now we mentioned that. What is the scan speed and the slit size? For smart lab, it's motorized. But for benchtop, we need to insert the slit by our own. So this is a divergent slit. Incident slit is divergent slit. Okay. Receiving slit, normally we open it unless we are doing the XRR in the floor set. And also you set, if you have any comment, you can put here. The option set here is if you have to, if you insert the spinning, you can change the separate spinning speed. Normally, I put 30 or 60. I won't put two. Sample might be spin off. Alright. And also, there is one special thing I want to mention. Our detector is 1D detector. What's the difference 0D, 1D, 2D? So imagine that you have the refraction dividing. That's how we mention that. You only take one line. You want to scan it fast, you scan by line. Kalau 0D, you scan by spot. Take very long time. 1D is scan like you can imagine a line of the 0D become 1D. So that's why 14 minutes of the 1D detector quality equivalent to 1 day 0D detector punya quality. So 0D intensity will be much lower, 150 times compared to 1D. It's not expensive issue. It's the detector technology limitation. But for the current technology, all are using 1D and above. So shouldn't be have issue like this. Okay. So if 2D, how? You can scan the area field. You can see the grid instead of one line. You can see whether your sample is spotty or not. Okay, there is a 2D detector. And also our detector, one thing, equipped with the fluorescence mode. So when the X-ray thing shine on your sample, the copper K alpha will be refracted. This is what we want because XRD, X-ray diffraction. But when the X-ray shine on the sample, like XRF as well, we will produce fluorescence. It will excite the Fe. So it will cause the background become higher. So we can use the fluorescence mode to suppress the background. For Fe and for bulk sample, if you're using copper K alpha, it depends on the wavelength of your sources. In a way, you have a window. Tapi what we want is only copper K alpha, which is reflected from the sampler, right? So we will narrow down the gate of the window. We see the copper K alpha, but coincidentally, if your sample have Fe, the wavelength is near the copper K alpha, it will enter the detector as well. So we further close it down until we only see K alpha. There is a feature what we call fluorescence mode. Here, the detector. There's one selection for the we want XRF reduction. Yes. This is 0D. This is 1D. And then this is reduction with 1D. 1D with reduction. So normally the peak will floating. But as I mentioned, just now the data quality, 5 things that sensitivity, resolution, peak to background, signal to noise. So peak to background penting also important. So we need to lower down the background. We need to use this mode for Fe and cobalt sample if using. Okay. So now, any volunteer want to conduct the measurement? So we will be starting from 10. So okay. Halfway you can click this paper top to decide where you set that. So I have created a file for frequency and training. Let's stop. Internet training. Put here sample what is this? Sample C, right?
Oh.
Okay. So now we enter the sample name. No. Sample name is sample C. And then the the peak we want to cover is 10 to 90. 10 to 90. So you put start from 10 to 90 degree. Because normally the sodium chloride peak will be appearing in this region. 90. And then the step using your value. Yes. So the speed put in a basket 10 degree per minute. So we will only need 9 minutes. 9 minutes to conduct the measurement. Okay, then you can close the door and start the measurement. Start. Like this, right? So once the measurement starts, the door should be off. Okay, so far any questions? No. Okay, we have 10 minutes. So anything want to discuss now about the machine? Alignment, measurement, not below 3. Because the direct beam, if you measure below 3, the X-ray beam will direct straight towards the detector. Spoil the detector if you shine too long the time. So that's why we always start from 3. Same thing we start from 0. If you start from 0, like some small angle express scattering, you need to have a spatial direct beam stopper. One is different cases. So in SRD, this is a reflection geometry required. Reflection is a diffraction. So we have also another geometry called transmission. Sample put like this, X-ray come in, you will transmit through all the this is reflection. Transmission is like this, and then you will scan like this. That one only capable to run it at the process. So there is a big difference between this also. This only can be do this can be do the Bragg Bentano PV, but process can be PV, and that's why if you are looking on the high resolution XRD, thin film XRD, it's more towards the process. Let's say we have 10 minutes now, maybe I brief a little bit. Other than the XRD powder method. Now we are talking powder all the time. This is a common. But if let's say I receive a sample, I have a sample like this. My sample is caught above. I can't get a signal for the coating layer. What should I do? We can use the PV to run raising incidence. So we fix the X-ray sources at the low angle, we only move the detector. Why we fix the sources? As the angle go up, the penetration of the X-ray will increase. So instead of giving the intensity from the coating, it will give the intensity from the substrate. So we want to control the penetration. We purposely fix the incident angle at the low angle, so that the X-ray only shine on the film or the coating of instead of. Okay. And also we have XRR to determine the thickness of the film, quantity of the film, roughness of the film. The high resolution study with the rocking curve. High resolution, what does that mean? Any idea? So we only have K alpha, right? Actually, there is K alpha 1, K alpha 2. How the X-rays produced? Any idea? X-ray produced in the X-ray tube. Yes, yeah, for sure. But what is happening inside the X-ray tube? You have the filament. You have the copper outside.
Yeah.
You have a window, right? It's like this. So the X-ray through the window. So you apply the current. It's a constant filament. You will heat up. The heat will produce electron. The electron will be shooting on the metal, which is copper in these cases. When the electron bombard the copper, it will produce copper K alpha characteristic of length. And then the K alpha will escape from the beryllium metal. Copper is target. Copper is target. So you can see the upper side is copper target and you flow with water, right? We need to cool down the target because over time you keep shooting the electron. The energy must be conserved. The target will heat up. So you need to carry out the energy, and otherwise the copper might be melted. So that's why you can never run a copper tube, or you can never run an X-ray tube without the water for sure. Because water is the best cooling medium. Okay. Okay. So I think we have another 2 minutes. So back to question just now, we have K alpha. Now in high resolution, we're talking about K alpha 1, not K alpha anymore. So when the electron shoot on the metal during the process, the copper, there is 1s2, 2s2, 2p6, the electron orbital. In chemistry, you all learn, right? 1s2, 2s2, 2p6, 3s2. If you notice, all of the electrons, they have a spin, upper spin and lower spin. And also, they must be in an even in order to stabilize before you fill in the another layer. And then once the electron kick out in the inner, the upper side will fill in the downside, right? Either the upper spin or lower spin will fill in. But the upper spin and lower spin will give a difference in the energy. That's why K alpha 1 and K alpha 2. From that orbital, we consider K alpha only. In powder, we only talk about K alpha. In high resolution XRD, K alpha 1. More precise. Okay. So you can see the peak at here. So now I will give you a handout for all of you. Please take your answer sheet just now. So each of you get one handout. So do you have any idea what is this? So you are given a database of the common material in our daily life. You have the cornstarch, in scientific name, amylose. You can have a D-mannitol sweetener, glucose. In the 99 mark, you have a glucose, right? The grape from the grape, the extract from the grape. MSG, Ajinomoto, salt, the baking soda, the sucrose, normal sugar, and the baking powder. So now, with the handheld provider, can you tell me what is this sample? Now you need to do the qualitative by your own. Later I will show in the software. Is it a salt? But you have to see the angle. That's all right. Up to 90. There's a different rotation you can see. The pitch is very intense. Okay, agree, everyone. So you can see, instead of just now, you are guessing around 15 minutes, 20 minutes. Make the things more easy with a proof, solid proof. It's a stop. Okay, now you all want to try another sample? Want to try the sample, maybe one sample powder? Maybe you can try with how you know which one is product? You haven't tried. Okay. So you have a series of the database, right, in your hand. But in actual, in the software, they have a millions of the database. This is only down to 8, that common one. Okay. So now you can text this powder. Now you won't operate by yourself. Okay. Want to try using granny full set preparation instead of water tester? Try using it.
The cross, not the same. Make sugar.
Not the same.
Oh,
We have glucose, sucrose, fructose, D-mannitol. Some of them are sweetener. Some of them are sugar. I mean, there's a real taste and give calories. If sweetener doesn't give any calories, just give a taste.
oh.
Just like zero Coke and normal Coke.
Okay.
So that's why zero Coke, they said, is much more healthier compared to Coke. That's the reason. So how you know from examining? You can all test the same. You see all the same. Want to try another one? Is which one? A. Say you all thought it's MSG, right? Yeah, see? Don't test it, huh? Don't test it. One of the sample is not edible.
Oh,
The baking powder is not edible.
but not toxic.
Okay, enough. Is it baking powder or cornstarch? Shake it out and then you know lah. It's okay. You scan, you get the pattern, you compare, you know. And then you verify the answer by your own. Now you can smell. You can know already. Right? Right? This one, clean it up. No worries. Edible one. This edible. You all try? We try another one sample lah, maybe, and then we proceed with the software qualification. Now is the manual qualification, right? So software and manual is different. Manual you need to actually in the old days, they have like a dictionary. Each sample, each material, each pattern, you need to fit one by one. You have to flip all the pages to find your match. But now, no need, software will do all the job. Yes. Then if you want to match one pattern, you need to take days at least. And some more, some of the bits are overlapping. They are stacking each other. So you can see it's like a straight figure. Yeah, what you think is like this, but you want to decode one by one. This is what we need to do. But when we decode, not only the pattern, we need to know the sample background. If you want to do a good qualification result, I mean, if you want to identify, you need to know the sample background. It was impossible you found a meteorite material in our material, impossible. So you need to think about that. Just like a small FIP, like the sample we receive. This is normally how we do that. So running process, all okay? Okay. So is it fun? Work like this? Or maintenance? Lagi okay. Maintenance. Ini banyak teori kan. This a lot of question. Yes. We need to know the fundamental. But this is some common for this session, 4 hours session. These are some common knowledge for the XRD. Very basic one. Oh, next. Không phải you use a coffee seed. Oh yeah, can. Right. Just a different size, right? So, ever think about how to apply this in your daily life? Like the supplement, just like last time I intern student, I think his friend, her friend, buying a supplement, claiming that this is from Ipsen or whatever, like, and then they scan with the SRB, they found out mainly is composed of the sucrose, which is sugar. Yes. So the supplement, maybe the API, the active ingredient, is below the few percent. So that's why this machine or this technique is very helping in our daily life. When we're doing the justification, whether the product is okay or not, is good or not, is true or not, sometimes some failure analysis, you can done it with this technique as well. It's a very powerful technique. You want to prepare one? I'm not. Oh, that one. Okay, okay. Let's wait for that one. And then I copy the result. We have a look here. We do a justification with your hands up. And then I will show with the software qualification as well. And then we will end for this. So any questions so far? No. Okay. If the sample is like wood, there's a fiber, right? It still can be done, but you need to ensure a flat surface. And the wood is like this. When you scan, the plane may be in this direction. It will appear. If you scan like this, the plane for this not appearing. So that's why some of the intensity will be varied. You scan in different directions in the wood sample. Normally for R&D, XRD is a must. Other than the elemental, we need to know the structure. If, oh yes, if you find ground the sample, then you can measure the sample. Yes. Yes. What is that powder? Is that okay? Now we can scan the second sample, repeat the step and scan the second sample. Yes, open. When it's blinking, you can open. So you can see after it's scan, you will give some X-ray irradiation effect in some of the sample. But now when you can see the size, just now the slit you will put, actually the slit is very small. But when the area came to on the sample, it's different. So limiting is controlled here. Incident is controlled here. Yeah, everything is possible. Yeah.
Oh, analysis.
That later I will show that now the analysis is quantitative and quantitative. Just now what we done using the handout to compare is a conventional qualitative. Later I will show the modern qualitative. Quantitative we won't cover on this session because quantitative I can talk for weeks.
So let's say now we only use the data thing. We have the x 0.3, like 0.1, something like that. How we define whenever we have one.
Okay. First depends on the resolution we want to achieve.
No lah.
Yes.
No lah.
That's why in a proper practice, we always need to run a brief profile scan to decide what the scan speed, scanning time, what are the speed we want to use. All of these are concerned for in R&D. But for industry, they don't even bother about that because they already optimize. They will keep repeating because this is their routine. So you can see now, get your head up and try to compare what it is. Go get your head up. Oh. Huh? We start from here. So you need to cover from here. This is sample one. F. Try to look for that. Which one is safe? The pattern. Betul. Dia ada dua pix ni. There are two pix. Right, there are two pix. Can see this is how we do the thing stuff. Is a whole way. If you don't have the software, you need to search through the internet to match the pattern. Yes. But if you have a database, later I will show in the software. Very easy. Very, very easy. So let's wait for it to finish. So is that possible? There's another material. What do you think? No, right? Are you sure it's baking powder, baking soda? We are measuring air, right? We are measuring air. Right. So you just hide it away. Sometimes the intensity will be different based on the sample condition. So if you notice some of the peak, if you're referring to other peak, here akan it will appear before 10. Then we need to scan from below 10. In that case, we need to change the incidence rate. Because the incidence rate, although you put 1.25, but when you shine on the sample at lower angle, it will become wider and wider. So that's why you need to change the
the smallest. Because if you notice, the volume of the sample amount must be constant. Although the depth is different, but the volume is the same. At the low angle, it's like this. Medium angle, like this. High angle, like this. But the volume is the same if you calculate that. The volume must be constant. Otherwise, at the low angle, you miss up some volume. Intensity will lower. You will notice the behind intensity will be higher. The front part intensity will be a little bit off because of the signal loss. Signal will shoot on the or diffract from the sample holder instead of the sample. So that is the point we want to optimize. To change the sleep, that what is measurement configuration, the spec. So everyone agree? MSCF? Breaking order, sorry, breaking order. Want to try another one also okay. Dapat ya mau konsumen ada yang untuk dia ada so the sample need to be dry. Yes, possible. If not dry, sample dissolve, this spacing change, it give you no fix. If the sample won't dissolve, still the water will absorb part of the X-ray intensity. Sample need to be dry. Only dry, yes. Preparing with another batch of sample. Let's wait for them. So far, not crystal clear, right? For the application, all the fundamentals. After they put in, and then we proceed with the software, and then we will jump to assessment. Sometimes I doubting the materials of the product I have purchased. I scan it over here. Oh, yes. I doubt it. Whether is it why it costs so expensive? Is it the material is correct? I get the things, I match it, I find the internet. I make my own justification whether it's worth or not for me to use the product for the price. Sometimes then if you notice out, the price is the same. The price is different, the quality is the same. And definitely you will choose the cheaper one. Because we are buying the branding, not material. It's like the aluminium foil we are using in our daily life for cooking. Aluminium foil, they have some Fe impurities. So we have tried the DIY, the diamond brand, then it will give a different result, a different percentage of the Fe. Because to break, you need to control the Fe. Because the Fe, it might be oxidized, become a heavy metal, we can get toxic by the Fe2 or 3. So that's why people always say the boiled water you cannot cook for another time because the water consisting of Fe You cook it, some of it become Fe2 or 3 oxidized. You cook furthermore, more of that will be appeared. And then you bring more Fe2 or 3 into your body. That's the reason, actually. So only boil for once, never boil for twice. Okay, is there anything of it? We'll copy the result and then let's back to our seat. Okay, let's go. So now I believe all of you already get your answer by referring to your handout. What are the mystery solids, right? So now look back on your answer. Did you answer it correctly? Now, how confident you are when you give this answer? Very confident, right? Why? Because you have the proof, correct? Okay. Now, let me show the modern qualitative way. Then we open the SmartLab Studio. Okay. I'm duplicating the script. Take some time here. Okay, so in the software, these are the software, they have a different version. So for measurement, is written XRD measurement, but for analysis, is written powder XRD. So you can see in this software, you can do the XRR, XRD, different plugins, we call it plugins. So now we choose for powder. And in powder, now we go for basic because we are looking for qualification on it. Okay, so you choose the basic. It will give you the flow chart. Just follow the sequence. So we log the data. Whereas we log the data. Sample C, right? Okay. It will give you the big like this. So now, if you have a first data log, after that we follow with the template. If you have the template is for industry use. They have a production line, ulang-alik, sample summer. So they will develop a template. You don't need to every time to look for the potential phases. But for this, we don't have that. So we straight away jump to evaluation. But what is the evaluation means? So if you notice, you see two lines. Can you tell me what's the line? Blue and the red, correct? The red is the major data, the real raw data. The blue is calculated. So why do we need to calculate the data? Because we need to do the fitting, the blue and the red overlap, then we get the pick list from the blue line. Okay, so that's why the blue and the red must as close as possible. The percentage is written here. How many percent difference between the blue and the red? Clear? Why does it important? After we do a complete matching, it's not a matching yet, it's a fitting to calculate the pick list. In the later, actually there is a pick list in the handout I given to you, all right? There is a pick list. Okay, for example, like this. Let's say, let's look for the sodium baking soda. You can see this is the certificate. This is a series. What is a blend? What is the intensity? What is the angle? That give you the pattern list. So they are referring with the pick list now we have. You will do a potential search in the database for each of the material in the database. So this is very important. This will decide what are the phases came up in the later section. So don't ever skip this step if you found that the blue and the red line are not overlapped, because you are registering the wrong pick list. Okay? So you can pay attention to the pick. The first is 27, right? Well, because I added, but then it's not big. After I refine, the intensity is very, very low. So you can neglect it. It's not a big actually. So the system will automatically find the best fit. Okay, between the blue and the red. Red you cannot modify. It's a raw. So you adjust the blue from the equation of the blue, you get this. And you have two data. You have the intensity. You have the FWHM. So these are all the profile details. If pattern, you only look for two data, intensity. Okay, clear? So now, if you satisfied, we need to go through the thing, whether all the blue and the red are overlapped. Agree, right? So now, if you satisfied, then with the approved pick list, we look for database. So for database, at here, search match. First of all, you need to have a database. So in my PC, I have the database of the TDF, the common database, the highest tier database for XID. Some we got two demo lah, came together with the system. So now, the most important thing is, why do we need the XRF data? We need to do a filter. Otherwise, all some weird things will come out. Now, I search the data without filter. For sure, you were able to catch up. This is what material. A lot of noises. You can see run. You can see. This is not the sample. It's not. You can see CEOF. It doesn't. You can see the pattern, and also it doesn't make any sense. So I know it's halide because of the preferred orientation. Because a crystal, they have a preferred faces that will scan by XRD. You can imagine XRD, you need a spherical particle so that it will scatter and give a perfect ring. The ring like this. Now I open the database. This is a database. Okay. You don't have database, you need to do in conventional way lah. So now, NaCl, right? You can see this is a pattern. It should have a very good ring like this. What is the plan? The highest peak is 31, right? You have a look at the sodium, NaCl, sodium chloride. 31.69, around it, right? Or you have a peak this here. You can see you have a peak this here. Here. Okay, but now what we get, the ring must be spotty. So that's why the peak intensity doesn't match. But now, if let's say later I use the river refinement, this issue will be eliminated. No issue. It's still able to feedback. Okay. So now you can see it's a NaCl. So for these cases, just now you can see when I use the common without any filter, you can see it gives you a lot of the weird things. But how do we know whether in your sample consists of not? That's one. You need XRF to find whether your sample consists of this element. So that's why when we do matching, I know it's NaCl. In the XRF, I get NaCl. I always not included. And then I always put CH and O as possible. So because in XRF, CH and O, it can't be observed using our system. Because our is benchtop. If you're having a flow stand, special crystal, yes. Okay, so it's NaCl. Okay. Right. Then all the noises will be very. You can see, it will suggest me the like with the how do you know? First, we always have qualification. When we justify something, we need to have a statistical support, visual support, all of those, right? Just now what we have done, how it flow, how it looks like the crystal, what is the shape. In the result, also same thing. You cannot simply tell that this is a pattern close to this. Then where is the support? First, XRF for sure. Second, FOM, figure of merit. The lower the figure of merit, the higher the probability of the phases appearing in your sample. Right? And then you can easily double click to see the big list. So it will match the big list here. So that's why I mentioned they will use a big list to find the big list here. If they found out quite similar, they will give you the potential phases. But still, we need to justify out whether the phase are correct or not. So you need to decide by the XRF support, sample background, all those. It's a series of the factor, or that will decide your justification. Okay, clear? So anyone want to try this another one sample? Now you log the data. And then you log the head. Just how I could see, right? Yes. First of all, you need to evaluate that. Zoom in, just red lines. You see all the blue and the red See, you miss out one bit. Yeah. Right. So how should you go to chart, click the X, and then you click refine. You will notice there is some drop in the RWT. Okay, refine. It's dropping, right? Because the blue and the red closer again. And then your peak list is like what you reflect in the blue light. Is it overlapping? And then you can drag across like this. It seems like okay, right? Satisfied, right? Right. So you can proceed to the next. This. And then you right click reset rule. Right click. Reset. Okay. Go to search menu. And then let's say we do have the XRF result. We spread the wave round. So the first one, this one, bismuth rhodium, do you think it's possible? No, right? So you can throw it back here. Okay, if you let's say you think this is a one, you click, you put it down. This is candidate. This is a search from the database. So this is a baking soda. Baking soda is sodium bicarbonate and HCO3. So you can see the blue line, green line, right? Is it a peak matching? It's just a vary in the intensity. Is it correct? You can refer to the blue and the red. Right? First, most important, we need to refer to peak position instead of intensity. Okay? So if you're satisfied, you set. That's all. Okay? Yeah. So there's a lot of things I can show, but I will show another one time. Another one thing, the real condition. This is for internal use only. I have done one. Just done this report yesterday. The sample, what you can tell from this graph. Is it a fully crystalline?
No.
Why?
The
This is a complicated sample in the real life. Just now it's pretty straightforward, all in the peaks, no background. Now you can see a hump. So I do the search match. These are some potential phases. With the support of XRF. Normally, you need to know the XRD detection limit. XRD cannot detect TTF, remember. It's only few percent, 0.1% normally, depends on sample. So you can ignore anything below than 0.5 or 1. We have 3 categories, major, minor, trace. You only consider major and minor in the search match. So that's why, and here, you can see, I open the solution, maybe you can all have a look. Okay, so you can see this is a result I get. And the fitting is very good, right? The blue color and the red color, can you see? And the WPTF is also very good. The lower the better. Okay. And you can see there's a lot of things you need to play around and how I search the material. Now the point is this is quantification. I don't want to go deep more on this. You can see how I search the things. I know the sample have been treated at elevated temperature, more than 100, more than 1000 to 200. Impossible, you still have a hydroxide form. Hydroxide bond will disappear. Only left oxide for sure. Carbon also gone up to 1000, won't appear. This is from the sample background I know. Then elemental composition. Now Si. Now Si. Ca, Fe. Ca, Fe. Ti là những input. Zirconium. But the others, I don't bother about it. It's in trace form. And then I put the search, and then you will give me all these potential things. But you need to justify by your own. Sometimes we give you some, you can see some weird things that is impossible in the sample after you treat with high temperature. So that's why justification, qualification is not only judged based on the pattern. You need to judge together with the sample background. Okay, clear? So very clear? All the process in details.
How to differentiate noise with it's very small.
Good question. First of all, noise like this, highest and lowest. Peak must be 3 times higher than the difference. It's a detection limit. If quantification limit, 9 times higher. It's in analytical chemistry, 3 times higher from the noise. You consider the peak. So this, like this, yes, consider a peak. But the noise is very low. It's above the detection limit, I would say. Okay. Any question before we go to conclusion? No.
So after we do the diagnostic, you can export the data in Excel.
Yes, Excel, PDF, paper report, up to you.
So for Excel, we will get us the calculate data.
Yes,
And the calculate and
yes, it will. It will give us 4 columns. First, to data. Second, calculated. Or observe, OBS, OBS, intensity observe. Third, ICAL, calculated. And the last, background. Okay, how you export the data? You just right click, export data. And then you change to CSV, export. I save in desktop. Oh, because I didn't include the calculate, I click away the calculate. If you need the calculate, you need to export here. This is a row only. So you export data. And you can see that it has the four things. Okay, intensity with the observed CPS observed in the background. So next, there's no more next. Let's recap what we have learned. There's no more next. Okay. So in summary and conclusion, so we go through one by one. Please answer me to see whether you really learned something today. How does the XRD works? The name? What's the name? So means that there is reflection on the sample. We are the Bragg law. So what is the equation of Bragg law? 2D sin theta equals to okay. So why material have their unique pattern? Why? Yes, correct. Agree? Because of the unique arrangement and the spacing of atoms. Okay? And it will give a specific exclusive signature and this. Then number 4, we go through the MOS. What is the proper sample preparation technique for XRD? There are 2 things, right?
Sample like particle size, like
And
basically area.
and centric area. Alright. How does the particle size affect the result? What happened to the intensity? Very right.
Very well.
And centric shifted. Okay. And also, other than the sample prep, measuring condition, speed and step. Okay, clear. There's another one factors is called geometry, but I won't touch on that. You get it correctly? Find uniform powder and pack it perfectly and smooth into the powder. In short terms, find flat. So I believe you all have learned how to check the flat, right? Flatness, check the fineness. Okay, and how fine should we achieve if possible? Then my thought that what is the theoretical lah. If you want to achieve 10 micron, you need to grind it for a very long time. And the mesh is no longer 300 mesh, it's 350. The mesh definition is per inch how many holes? 1 inch how many cm? 2.54 if I'm not mistaken. So you divide that, 254 you divide 350. And you come how many? It's okay, you all Google search it. And last, how to conduct? Can you tell me? Quantitative analysis for the XRD. First of all, what is qualitative first? We get the result and then we get the pattern. After that, how to conduct qualitative? Compare to the database. Okay, and then manually you're using booklet or a dictionary, okay, of the database. In software, just now I just show you right how easy was that. You don't need to go through pages by pages in the textbook. Okay, so match the unknown samples pattern against the database. to find the perfect reference. Okay, clear? So when customer asks you, remember to educate customer. Actually, XRD is not difficult. First of all, and also sample prep is very important. Need to always remind them. If possible, ask them to invest one lead if they have a lot of the sample, a lot of sample. If customer asks, how do I know whether my qualitative is correct or not? Just on my ratio, right? Yeah, from the F of N, from the comparison, right? How to log, you need to evaluate the peaks, right? There's not much step. Okay, still remember the peak framework I mentioned? This is our course outline. Right? So what are the peak? Key for what? Okay, yes, and also the fundamentals lah. A, analyze. Tahu analyze lah kan? Ada kenal? Manually lah. Okay. Software. Nanti kamu akan dibagi software. Okay. And K, know why the material have their own unique pattern. So at least you all can understand this whole question. That means that this training benefits you. Okay. Service is not about service the machine only. You need to at least know what are the components, how does this important for the machine to function. Then you can see the result, you're able to troubleshoot. Yeah. Right. This is how the troubleshooting process. Okay, so in conclusion, everything is a sample for SID, to be honest. You can scan your pen, scan your sheet of paper or anything. You can see I easily, to be honest, yesterday I purchased all of these sample from 99, all easily to obtain. All I buy from 99, below 15 ringgit. So everything is a sample for HRD, like I mentioned. If you're curious about something, you are free to use the machine anytime. I want to check out. No issue. Okay. This is to boost our confidence, our justification. Whether you put the money in the right thing or not in your daily life. If you want to apply, but in QA/QC, for sure you need this. Like Asia Literature, they are producing the lead oxide, right? Lead battery. So for sure they need to use this because lead, they have different raw material. Different raw material, different grade, different pricing to their supplier. This is how they decide their pricing. So that's why for them, and also different lead compounds will have a different treatment before they become lead battery. Okay. Actually, XRD is surrounded in our daily life. I mean, everything you can measure if you want. Yes.
And then how about liquid?
Liquid, yes, we do have a special method we use for capillarity. Let me show you. The tube, you need to put your liquid sample into the tube and then you scan it with the transmission method. Let me show you the picture. You can see. Next door. I do it. Dia akan spinning macam ni. Liquid XRD can be done, but the thing is, what are the things you want to see? You need to know your objective first. For your knowledge, we have a gold nanoparticle solution. You see from physical eye, like the rose syrup, red in color. But actually, there is a lot of gold nanoparticle inside. It will make the water become red. When you scan, the gold peak will appear. If you're looking for a solid in a liquid suspension, yes. If you only scan the bare liquid, alcohol or anything, you get nothing. Because liquid, like I mentioned, it will give you a cup only, right? Amorphous and low peaks. XR liquid can done XRD, can do XRD in conclusion. Okay, just based on your objective. Okay, any more questions?
Only for tanks.
The suspension in the liquid. You need to have a solid because solid it means undissolved. The atomic structure remains. Then it will give it a peak. Okay. If it dissolve, it become iron, it will move around. It won't give you a displacing, it will give you a peaks. Because the peaks is from this spacing, right? This spacing is the atomic length. You dissolve the atom no longer in the older state. Okay. Maybe each of you give a short 1 to 2 minutes what you have learned throughout this session, and then we end this session. Bro, give up. Mhm.
How to define the sample.
Most important, do you understand what is the peak about PAK? P is for you just now we have done for hours. That's okay. Explain, you need to explain the Bragg's law. Okay. Analyze, right?
Analyze.
You have done.
Analyze the sample.
Okay.
To know the
Have their own identity, right? Kenapa? Why? Material have their own identity, their own pattern, because of the difference in the distance, right? Distance between the atomic. For Cheryl?
I learned a lot. Terutamanya regarding the importance of sample prepping, because sometimes do our service job, sometimes we measure our reference sample with
Sifting.
prepping. So that one we cannot explain how, but after training, no, already.
Actually, it's from the way we prep the sample, right?
Yes, prep, the way we measure and how long we measure it. There's sometimes for a lot of noise. And also fully understand how to do the analysis part on the software side. Because for us, normally we just search it, refine, then step to report.
Or whatever it came out, give customer.
Yes, we just find for us at the SI, we suggested as a backup, but normally those investigate or
Alright. For that, now we already know how to define, let's say, the calculated it don't have the one not match that the thing that we measure. We can add on the thing lower
R-barbecue. R-barbecue lah.
yeah, R level. We don't want to do that well. Actually, all lah, but now it's more.
Now you know, at least you know how to do that, right?
Yes.
That's good.
So the first thing that I learned so much is that only after we done the measurement, stop there. So we do the analysis. So right now we understand how fully covered, right? There's benefits, but I start wondering, this is basic, right? What is more on the analysis or what?
Okay. So for basics, just to make the things clear, basic is very straightforward. What is the XRE about? What is the application? What are the qualitative? That's all. But for advanced, there's a lot of the thing you can get the materials inside from the pattern. Although the pattern itself, you can write a very long story. How it shift, when you drop something, the solid solution. These are some scientific terms. And then the advanced, yes, for sure will be more on analysis, for sure. And the analysis will cost you days to attend the courses if you're this. If you ever do analysis the data, you already a certified application team. One of us. Yes. Because to be honest, not that easy to do the analysis, especially when you need to go through a lot of the papers, search through the internet. Was the phase possible in that sample? Not only when it came out, give you the lowest FOM, sometimes the phase is not supposed inside the sample. That is only statistical, but it's not correlate to the sample background and also XRP. So it's a complete of series. We will be continuing improving our teaching module from time to time, so that all of our RGST will at least have a fundamental knowledge about the application and the usage of XRP. And also, I also hope that if possible, service team also can give a little bit training, because what I can learn is from bit by bit only. When the things happen, I can know the component, how does it fail, and then how I troubleshoot. I know how to troubleshoot, but how to fix a thing, sometimes I need to ask for guidance. Okay, that's good. Shaman?
I would lot of exactly for this I think but now I see thing analysis is hard. But that's gonna be specific on how to analyze the body picture. Look at the six and then yeah, itu semua lah. So right now can try to repetition to compare, see the view, and then the sample preparation for so I'm also if there's any machine that do sample preparation.
There is a special attachment, but unfortunately, because different sample, they have different sample properties, different hardness, different. Some of the sample are sticking, some are not. So up to that, no, as I understand that, no special equipment for sample preparation for SI, because we can easily use the things to mess it up. We only need machine to run the things in a more productive way. Maybe on the next session, I will discuss with my team, Hero, and then
all teams conduct another session. Intermediate level, not advanced yet. Advanced no need. Advanced is for customer. Intermediate, if you're able to understand, you're able to do the job, congratulations, you are very good enough. You are a competent personnel in our company. Okay. Okay, thanks for your sharing.
Exciting.
Mm.
Today I went on that scholarship I did. Great work.
Mm.
And then my son I did how to present presentation.
Mm.
Then I then have the last since I feel of the same it's for small exciting and it's quite happy.
But to be honest, you are quite lucky because they have worked for years. This is the very first time we have internal meeting for service team, to be honest. You can see Shami and Vikra, although they are quite, and also Sharon. So they already worked for 3 years, but you can see we are still asking some question about analysis. So that's why I noticed that issue. So that's why I decided to conduct a training, a basic at least to cover the knowledge lah. At least you know what is happening, and not everything always came back to us all the time, right? Maybe some of the time just a separate issue. Right? So yeah, lucky for you, and also Lipa. I will try to maintain this culture annually, so that you all can get the cert. You can put in your CV if you want. Okay. Okay. Thank you for your attention, for your time, and thanks for the patience for throughout these 4 hours to go through the games. Yeah. Thank you.